Um, Hi, hello everyone. My name is Adair. I am co-founder of Abstract Money. I'll be doing this presentation today on Boot in lieu of Cyber Howard, but I've got the cool CosmWasm shirt, so I don't know. It's a good compromise. So I guess yeah, we wanted to show you Boot because Boot allows for scripting your contracts, deploying your contracts, writing your integration tests fully in Rust. It's really easy to do this in the native language. We don't want to be like those EVM devs who write all their tests in TypeScript and while their contracts are still on Solidity. We love EVM though, but still, wouldn't it be nice if um, you could interact with all your contracts using Rust? And so that's why we built Boot. So what is Boot? Boot allows for CosmWasm interactions with your contracts, and um, and basically like when you interact with the contract in CosmWasm, you call an entry point on the contract. And of course, in CosmWasm, there's three different entry points. There's the instantiate, execute, query. I mean, there's a couple more. There's migrate and reply. But like the main ones where you're interacting with your contracts are instantiate, execute, and query. And so, yeah, as all of you are contract developers, this should be pretty standard to you. And it's really important to note that you want to have your integrations as tightly integrated to your message definitions as possible. So I guess the question stands like, how do you generally interact with your contracts, either on chain, in a mock environment, or off chains? Like, how do you do this? So typically, you can use the CLI, you can use front end, Python or JavaScript, or even Bash, and you take these messages and they're serialized by Serday, and you can call these entry points on your contract using JSON. And this gets sent to the SDK node, and it I guess does some verification and allows for interacting with your contracts through this standard interface. So, and what about in test environments? A lot of us write our tests probably in TypeScript, which is a little bit nicer to us than Rust, so it probably allows for faster testing. But a drawback to that is that all of our tests they could break once we change our standard our contract interface. Thank you. Sorry about that. So yeah, so let's take a look at how we interact with our contracts using CW multitest. This is a wonderful library. Allows us to write quite robust integration tests with all of our contracts. It is in Rust. And so here we have an example on the right of we're using the Astroport contracts because they have an excellent code base. So we define the message that we want to execute, and then we can we have this app object that like represents our environment, and we can execute the contract given the owner, the address of the contract, and then the message that we want to execute. And then same thing for querying. We create the query message and call it on the application as we do with the executions. So yeah, I'm gonna also show you an example in JavaScript. So these are actually Astroport's deployment scripts for all of their contracts. They do it all in TypeScript because it's really easy to it's a lot faster to write TypeScript, of course. But TypeScript's a little nicer too than Rust. So as you can see here, we get a new client, and with this client, we can actually interact with our contracts on chain. And yeah, it's pretty standard. Like we upload in the init, so we basically deploy all of these contracts, and that's about it. It looks quite clean. What if we could do this in Rust? So in Rust, it's a little bit more verbose. However, it's also a little bit more clear to the user what's happening there. So first, in Rust, we create the application. We have the owner, and then the controller, which helps initialize the environment. We create two users, and yeah, we interact with our contracts quite similarly um, in Rust. And this doesn't actually include everything that's happening over here in the Astroport deployments. But again, every time that you change your interfaces in Rust, your deployment scripts, your tests will all break. And that's actually a really good thing. We want our tests to break because it helps us um, create more secure smart contracts. Because yeah, when you it helps us create more secure contracts because we know when things break, and all of our integration tests will fail, and we don't have to wait for deploying it on an environment to know that. So what's the alternative? In CosmWasm, one of the design principles is the actor model, and the actor, of course, it's a single instantiation of any contract, and this can perform several actions. Um, and like so, you have this actor, and it performs these actions, and once it finishes, it figures out what did I do, and then it sends it off to the next actor, which and then each of these actors in sequence finish the tasks that need to be done. And so additionally, and I keep hitting this point hard, but if we keep our interactions in Rust closely aligned to our contracts, then we reduce the overhead for the developers because it's easier for them to interact with the contracts. It makes complete sense, and then it's also easier for the readers because they don't have to actually know additional languages beyond Rust. And so this is what we are trying to accomplish with Boot. We're trying to unify interacting with CosmWasm contracts in every single environment. And that's on-chain, like in mock environments, on your local chains. Um, yeah. So I want to introduce you to how we interface with our contracts in Boot. So right here, we have a struct that represents a given contract, and we pass in a generic for the environment on which we're deploying our contracts. And this environment stays with the contract the entire time and allows us to access certain aspects of that environment. We can check balances, we can set balances, we can call as different senders, and it's fully knowledgeable about each of the endpoints that it needs to reach out to on-chain or in your mock environment. So yeah, so the first attribute in the struct is the ID of the contract. And we can really call this anything. We generally follow the crates standard, which is a namespace or like the provider, followed by a colon and the name of the contract. So for instance, this could be like abstract account factory would be the ID of this contract. And this ID is used as a key to store the addresses of the contract, the code IDs, and every version that you deploy. We want to make sure that developers have access to all of the like the state that's on chain, and we just do that through through this ID because when you deploy your contracts, it figures out you have to upload it, you get the code ID, you deploy or instantiate it, you get an address, and then if you have different versions of the contract, for instance, if you're trying to migrate it, then it'll store like like a separate item for those different versions. The second attribute in the Boot contract interface is the source, and this is where you provide the reference to like where the WASM for your contract is. This is generally like a local WASM that you've optimized via optimizer, and in the future we may add support for retrieving it from remote endpoints, but we're not sure if that's actually as secure as we'd like it to be. So this points to the contract source, and using this contract source, we can upload our contracts and get the checksums and so on and so forth. Now, the third attribute in our boot contract interface is the actual chain. We store this in the struct, as I mentioned, so that you can interact with your environment and edit it. This is similar to in multi-test, where you have the app variable and you can interact with your environment there. And so this chain object is actually a lot of the methods that you call behind the scenes, interacts with this chain and executes queries, whatever, on your contracts. Yes, and I guess I jumped a little bit forward on this chain generic variable, but since CosmWasm is chain agnostic, all of our scripts should also be chain agnostic. We don't want to be bound by any constraints. I know that Terra has, or at least old Terra 1, I'm not sure what we're calling it, Terra Classic, has a little bit it has a few alternative ways of interacting with the contracts on chain, and we can actually abstract this away since everything is done through traits within boot. So we can create environments for CosmWasm VM uncomposable, for instance, or like landslide environments. And this allows us to interact with every possibility that we have to the extent that, or every environment that CosmWasm supports. So, yeah. Now, for each of your contracts, we also define, within boot, we define the CosmWasm interface for your contracts. This holds the types for your contracts, including the 4 main entry points. And this allows for interactions with your contracts really easily, and all of your methods, when you call execute, it only accepts an execute message. It won't let you pass in some execute message from another contract. And this is to increase developer safety and increase contract deployment safety. And just as a note, this is all hidden behind the scenes. We've pulled out all of this boilerplate code into a really nice macro that you can use as a developer to interact with your contracts. And yeah, so right here, I have an example of the CW plus CW20 base contract. As I mentioned up here, we have I'm not sure if you can see my pointer, but I'm looking at pub_struct CW20 base. And above it, we have the contract. We're passing in each of the entry points for the contract. And this struct implements the traits and also defines the contract interface that I mentioned earlier. So not only does it implement these traits and define the interface, but it also allows you to add additional implementations. So one of the really cool things about boot is it's completely interoperable between code bases and between teams. You can export this struct along with your, generally you can do it along with your messages, because when you publish your packages, you want other teams and other developers to be able to use your packages. And so you can export this struct, and then other teams will have access to your implementations on the struct. And these implementations, let's say you have a really advanced, I'll give you an example with abstract. We have maybe 14 or 15 contracts that we deploy when we deploy abstract. And so we have a function within the abstract contracts that allows you to completely deploy them. And it does all of the interactions that you need to set up all of the contracts. And it makes it really easy for people using the abstract SDK to use abstract in their test environments, because it's one line. So let's break down this new function then. So if we go in here, we pass in the ID of the contract, and then the chain environment, yeah. So And then using those, we can also get the manifest directory and the file path for our contract. And this is set in the source, which we can see down here with WASM path. And we're passing in the file path. And this recognizes that there is a WASM file here. And this will be stored in your contract and allow you to upload that specific WASM file. Excuse me. Yeah, and the create path is just one of Rust environment variables that allows you to set the local path. Another thing that Boot does, it has a lot of environment variables. So you can actually set this, the base path in Boot so that it could be a different directory in your system, which makes it really easy to deploy your contracts no matter where the WASMs are. The second thing you may notice is this with mock function call, or like builder call. So right here, we can actually pass in each of the I guess, exposed entry points in our contract, including execute, instantiate, query, and migrate. And this allows you to use the CW20 base struct in your integration test. And of course, if you don't want to expose your implementations here, you can actually omit this and then have the downstream consumers implement like some mocks, or you can implement some mocks yourself. So example CW20 base. So I'd like to show you this contract in code. So I'm going to switch my screen sharing from whatever this is to my IDE, which is already in presentation mode. Excuse me. Screen. I'm just going to share my entire screen. It's a lot easier. So, hello. And I hope this is big enough, but let me show you the CW20 base contract for Boot. So as mentioned here, we just instantiated a new contract, passing in the ID, chain, and source. And we can actually just see everything that's on here. And yeah, so if we were to use this CW20 base, we can actually look at one of the wrappers that we've provided as an example. And by the way, all of these examples are available in the Boot repository, which is abstract-os/boot on GitHub. So we have a struct that wraps all of the CW plus contracts and then implements the deploy trait that we also have with Boot that allows you to store all of them and deploy all of them at once. So you can also load existing ones from the chain because we don't want to bloat the chain state. And so we have, so that we prevent ourselves from re-uploading contracts if they already exist. Yes. And finally, I'd like to show you an interaction with these contracts on a real environment. So this is an example deployment script for the CW20 contract. And I'll just go over some of the key function calls. We can ignore the runtime, but so right here is one of the more important parts is we provide the actual daemon options for the environment that we want to interact with. So we have a builder for this, and we provide the network, which is in this example Uni 6. Shout out to Juno, but we can actually also pass in Constantine 1 as the network, and we can deploy on Archway like directly using Boot, and we pass in the deployment ID. And of course, we build the options and we pass it in to a function that's exposed from the Boot core, which is instantiating the daemon env. And we don't have to look at this. It's a little bit, this is all hidden behind the scenes. So yeah. And so now using this instantiated daemon env, we have this chain that represents the daemon, and we can call our example once again. All right. So as I mentioned, your chain environment allows you to request information from the chain, but it also stores, for instance, the sender. And yeah, we can actually look at the transaction handler for this chain that exposes a lot of the methods that we may want to use in any environment. But I will go over this later. Back. So let's first upload our contracts. We store it on the chain, and then we receive, and I'm coming from Java, so excuse my terminology. I'm going to call this an object. The CW plus object that allows you to, yeah, this is the wrapper around all the CW plus contracts. So using the store on call, we've just uploaded all of them to chain, and now we have this object, and we can break out the CW20 base structured from the CW plus object, and then define the instantiate message. So this is how you typically do it, right? You typically say, all right, instantiate, given this message, we'll pass in all of the attributes for this instantiate message, and we call instantiate. Yeah. Well, I jumped ahead of myself there, but let's also look at an example transfer. This looks very, very standard. So here we're sending some tokens to the recipient address with 100, and we can execute this directly on the CW20 base contract, and this will execute it on chain. Same with queries, looks quite standard, right? What if I told you that you actually didn't have to build these messages, which are quite verbose sometimes, especially like this instantiate message. It has 1, 2, 3, 4, 5, 6 variables, and yeah, that can be a pain. So by using this boot struct, we actually have implementations that are auto-generated to call methods on your contract directly. So right here, I'm clicking into this balance query, and I'm just like command clicking into it, and you can see it's derived from the query functions derivation that's provided by boot. You can actually include this on each of your messages, and this allows you to build these messages in the background and just execute them via parameters. Yeah, so now we've gotten the balance response, and this is fully typed. It knows each of the messages are supposed to provide, and so yeah, you can see that right here. Same with the execute messages. Right here, we can transfer 100 to the recipient address, and doesn't this read so much nicer to you as the developer and the user? Yes. So yes, and then we can do our assertion, and we press OK. So why don't we actually run this example? I don't believe that I have any tokens on my Constantine address here, so I will be using. Let's just try it out. Let's see if we can actually run it on Constantine. I might have some. Okay. So we'll run this example, and of course it's in the boot CW plus examples. And oh, sorry, let me explode my terminal higher. So this is actually on debug mode. So excuse me, let me turn off this and turn it on to info, and then rerun this. It'll be a lot nicer. So right here we have yes, okay. So I do not have any tokens on Constantine. Sorry about that. So we'll run the example using Uni 6 and using the daemon. If my terminal would like to comply. Otherwise, while that's trying to figure itself out, I can actually show you an example of an integration test, also written using boot. So yeah, first we upload down here using our address, and this is derived from our n variable. I won't show you my full private key, but if you want to crack it using 5, then go right ahead. So yeah, now we have uploaded the CW20 base, and we have the transaction ID down here just as a reference. And the second thing that happens, actually, I'm not going to run this example because this is going to upload every single contract in CW Plus. So, so sorry about that. I meant just to deploy the CW20 base contract, but the script will run through, instantiate it, and then send some of the example tokens to the recipient. Okay, okay, yes. And this recipient address is also fake, so yeah. What else? Oh yes, I'm going to show you the daemon. Command Shift. CW plus mock. Actually, I'm going to show you the mock. It's the same example down here, but all we have to do to write integration test is to instantiate the default mock environment, and we have the integration test. So let me see about these slides. Boot workshop. Yes, showed you that. Oh yeah, so as I mentioned, this allows for collaborations between teams. I know you can see my my speaker notes over here, but it's okay. So teams can publish not only their bootstraps, but they can also publish integration bundles. So right here, we have an integration bundle with Windex, and it would be really easy for us to build an integration bundle with Astrovault deployed on Archway. And this way, like all the teams will be able to use Astrovault's contracts and be able to test them. Because at Abstract, we actually have a lot of integrations with DEXs through our DEX API, and we want to be able to make sure that our implementations don't break. So we have our canaries written in Boot that use these integrations. All right, and so yeah, well, you've probably heard of some of these other scripting libraries such as Beaker or CW deploy. But yeah, as you can see here, both Boot and Beaker have really clean syntax. In Bash, it's ugly. Shame on you if you're writing a deployment scripts in Bash, but it's okay. Boot is here for you. We've also got our contract deployments in all of them. It's really easy. But Boot is the only one that's Rust native, supports CW multi-test, and is shareable between teams. So feel free to make some PRs on Boot. And yeah, I'd like to open this workshop to questions if that's possible. If not, then yeah. Is anyone else here?
Sorry about that. All good. Thanks, thanks Adair for your time. I really do appreciate it. So some questions I had is, so for the developers listening today, where can they go to get some more support and view these files? Is it open source? Like where can they go to get some more support and find out more?
Yeah, that's a great question. So it is fully open source, and where would be best to post these links? I can also just type them on a slide real quick.
Yeah, I think maybe perhaps type them on a slide, and then people can watch this back and see.
Yeah, definitely. So I'll include Boot, and I'll include a link to our Discord where you can actually interact with other developers building on Boot. We have DAO who is building Boot integrations, and we've spoken with the Astroport team who's also doing Boot integrations, and it's just yeah. So let me plot this on a slide real quick. So yeah, and it's again it's abstractos/boot, and share screen present. Yes, and so yeah, I'll just show we've got abstractos/boot, and we have our Discord link over here using an insecure URL.
Cool. We'll leave that up there for the viewers to see. Perfect. All right. Well, Thank you very much, Adair, for your time today and for sharing all of this fantastic insight with us today. Obviously, we really do appreciate your time, and the community appreciates your time. So for anyone in the audience listening, the Archway Hackathon is currently live on DoraHacks.io, and there is still plenty of time to submit your build. So there's a bunch of prizes to be won. So if you're building, make sure to submit. And if anyone does have any questions, please feel free to reach out to myself, the Archway team, or Adair here via social media platforms, Discord channels, or Telegram. And if you haven't already, please make sure that you do follow DoraHacks on Twitter, Discord, and Telegram to stay up to date with the upcoming sessions like today that we have in store for you. So thanks again, guys, and thanks Adair for your time today.
Yeah, thank you so much, George. And yeah, see you later.